Study of solving equations, and this time we're going to look at what happens when you have variables on both sides. Okay, and so if you look up here on the board, notice I have 2 plus 5k equals 3k minus 6. So now what we need to do is we need to combine those k's. Now one of the things I always like to do is I always like to keep my variable positive, so I find the largest one. The largest one here is 5. Okay, so what that means is I'm going to move the 3k over to the 5. And so how do I move the 3k over? What do I do?
Subtract.
Subtract, because it's a positive here, so I'm going to use do a negative. So I'm going to subtract 3k from both sides. Now on the left side, what ends up happening is I have 2 plus, what is 5k minus 3k? 2k. And that's from what we learned about in chapter 1. Now the 3k minus 3k means those cancel, and that leaves you with negative 6. So now this is an equation that you had yesterday and the days before. Okay, it's a two-step equation. So now to solve that for k, what do? Subtract 2. So on the left side, what ends up happening is you've got 2 minus 2, which is 0. That's gone. And I've got my 2k. Over here, I've got a negative 6 and a negative 2, which is negative 8. To solve for k, I divide by 2. Very good. So I end up getting k to equal negative 4. Very good. Okay, so it's just a multiple step. So now what you're doing in place is you're just moving the k over, or the variable over. So with that in mind, I want you to go ahead and solve this one. Okay, I want you to go ahead and solve that one. You're going to get a fraction on this one, and that's okay. Okay, so if you get a fraction and you think that you did the problem wrong, you didn't. So it should be 7 plus 2 equals 6. So 7 plus 2 There you go. Yep, reduce that. You should be good. All right, 1/3. Okay, so let's look at that real quick. Okay, what we do here is you should have added 7a to both sides. Okay, so you get 12a plus 2 equals 6. Now I'm going to subtract 2 from both sides, and so I get 12a to equal 4. To solve that now, I'm going to divide by 12. So I should get a to equal 4/12, but I know that reduces to 1/3. Okay, because 4 goes into 4 one time, 4 goes into 12 3 times. Okay, let's look at another one. Now this one I'm going to get you started on. Okay, just because it's kind of written a little funny. So you have x over 2 plus 1 equals 1/4 x minus 6. Now does somebody know another way that I can write x over 2? Okay, maybe a way that would fit better in the problem than what it is now. Okay, this is a fraction, right? What number's in front of the x? A 1. So really, this is nothing more than 1/2 x. Do you see how that works a little better? Because if you have some number times x, that's a little bit better to understand than like the variable divided by. So really, this is what I have. So now I need to think about things. I need to combine my x's, right? So what am I going to do?
Subtract 1/4 and 1/2.
Yep. So I'm going to subtract 1/4 x from both sides. Okay. So if I think about that, what's 1/2 minus 1/4? So if you have a $50 and you subtract a quarter from it, what do you have left? You have what? 1/4. You have 1/4 left, right? So 1/4 x plus 1 equals -6. I want you to finish this one for me. When you get your answer, I want you to put it in the expressions. we have negative 25. Or actually negative 28, I take that back. So let's see, we have positive 28. So, you know, the good thing is we at least did the steps right, we just forgot the negative. Okay, because notice here, when I subtract 1, I should have gotten a negative 7. So when you end up getting this and multiplying by 4, you should have a negative 28. So that's just one thing you just need to make sure that you don't forget. Okay, so let's look at this one. This deals with decimals. Okay, what do you think you're going to do here? Okay. Okay. So,
You're gonna put that in zero.
okay, so tell me how to do that. Okay, good. Let's, you know what, I know I said it always is nice to keep n positive, but in this case, if you don't move the n's, you're going to actually have to do 2 moves. So this actually cuts down a little bit of work for you. So if I have 1.3 minus 3.3, really what could you do with the 0.3s? You can kind of just disregard them because they're the same, right? So basically I have 1 minus 3. So what's 1 minus 3? Negative 2, very good. Okay, so now what I need you to do is solve that for me. Okay, now don't forget that negative sign. Okay, don't forget that negative sign in your answer.
You can put the answer on.
Oh! Okay, sorry. There you go. All right, negative 1.4. Good job. Okay, because what we do is we take 2.8 and we divide it by 2. Okay, that's how you undo that. Oh, let's go back. All right, so let's look at this one. 6 times the quantity, 5n minus 3, equals 1/3 times the quantity, 24m plus 12. So what's the very first thing you think you're going to do in this problem? Distribute. Okay, whenever you see that number outside, let's distribute. And so let's think about things. What is 6 times 5m? 30m. Very good. What is 6 times your negative 3? Negative 18. And that's going to equal. Now when you have that 1/3 outside, I know some of you fractions just kind of throw you off. This is what you can do. 1/3 basically means divide by 3. So if you take 24m and you divide 24 by 3, what do you get? 8m, right? So now I'm going to do the same thing with the 12, because 12 times 1/3 is nothing more than 12 divided by 3. So what is 12 divided by 3? 4. Okay, I want you to finish that one for me. Okay? You finish that one for me. So you should have got an answer to B1. Nice job, guys. Way to go. Okay, so now they're obviously not going to all be that easy. Okay, look at this one. This one's kind of a doozy. It's going to take a few steps. So these last few problems we're going to look at are a little bit more in depth. We're not going to use the expressions. We're going to work through these together in class. So let's go ahead and look at that first one. What do you think you're going to do? Distribute. Yep, you're going to distribute that 3. So I'm going to leave that 5x plus 5 alone for right now. What do I get when I distribute the 3? 15x minus 12. Okay. Now we're close to some of the previous problems, but we're not quite there yet because the previous problem had a variable and a number. So if I notice here, I've got a 15x here and a minus 10x here. So I'm going to combine those together. Okay, so first of all over here I have 5x plus 5 equals, what is 15x minus 10x? 5. So I really get 5x minus 12. Now I need to combine variables, correct? So what do I do? Subtract 5x. So let's move the 5x over here. So I get 5x minus 5x. Those cancel, right? What does that leave me with on that side? 5. Oh, I've got 5x minus 5x. Oh, well those cancel too. And what does that leave me with? Negative 12. So I want you to think about this. Does 5 ever equal negative 12? Never. Doesn't equal it. So since it never equals it, this is one of those statements that never happens. It's never true. And so this is what we call a no solution. So you're probably wondering, what is that symbol that she wrote? Okay, that means no solution. So you have 2 answers here that you could write. You could either write out the words no solution, okay, or you could do the symbol. It doesn't matter. So the symbol or no solution. And that happens when you have an untrue statement. Okay, let's look at this one. Okay. What's the very first thing you're going to do? Distribute. Okay. So let's go ahead and distribute. What do you get when you distribute? Yep. Keep going. You're on a roll. Minus 3. Good. So if you remember back to the previous problem, we looked for like terms, things we could add together. Do we have anything we can add together here? The negative 3 and the negative 7. What is negative 3 and negative 7? Negative 10. Good. What do you do now? Yep. So let's subtract 6m. What am I left with? On the left side. Yep. Negative 10 on the left side. What do I get on the right side? Oh. Now is that a true statement? Okay, so when you have something like this where it is a true statement, you have another special answer. This one isn't a no solution. This one is an all real numbers. Now what that means? That means that every number you would plug in there for m will work. You could plug in 1, 10, 20, 50, 100, and it's all going to work. You could plug in 1.3, negative 1.9. Anything you plug in here will work, and so that's what this says. So when it's a false statement, it's no solution. When it's a true statement, it's all real numbers. Alrighty, let's look at this one. Actually, you know what? I want you to do this one for me. Okay? You do this one just quickly. I know you won't enter it in your expressions, but just do it, and I'm going to come around and check. Nice. Nice. All right, nice job, guys. You guys did a great job on that one. Okay, you ended up getting 30 to equal 20, or actually negative 30 to equal 20, and it didn't work, so that was a no solution. Good job. Okay, last one. Find the value of x so that the rectangles have the same perimeter. So I'm going to get you started on this. What do you know about perimeter? What is it? Perimeter? You add up all the sides, right? Because perimeter is the outside distance. You did area, okay? So perimeter is the outside distance. So I know that this side is 6 and this side is x. So if I add up everything on that rectangle, I have x plus 6 plus x plus 6, right? What does that simplify to be? I want one variable and one number. Okay, 2x plus 12. Now let's look at this one. Okay, this is x and this is 2x plus 2. So really, I get on this one x plus 2x plus 2 plus x plus 2x plus 2. Okay, and I'm going to add all those together. All right, so let's go ahead and figure out how many x's do I have. So let's see. 1, 2, 3. How many is this? 4, 6. So I have 6x plus what? 4. Yep, good. So now if they have the same perimeter, what do I know about each of those? They have to equal each other. So really, this is just an equation I need to solve. So I want you to go ahead and solve that, and then type in your answer on the expression if it's A, B, C, or D. Okay, but there's 2 and 2. Okay. See, here's your 1x, 3x, 4x, 6x. Look at what's left. Just the 2 and the 2. Okay, so that's where the 4 came from. Is that right, and the answer is 2. Nice job. You should have ended up getting 4x to equal 8. Okay, so this is what I need you to do for me for Monday. Okay, on pages 100 through 101, I need you to do numbers 10 through 38.